Dear friends, today we will be discussing processing of vegetables. Vegetables are nutritious and one of the excellent sources of vitamins and minerals, apart being laden with riches of dietary fiber. Since times immemorial, they had been important part of human diet, but over some decades their consumption has increased significantly among the health conscious masses due to their role in prevention of many non-communicable diseases. They are also an important constituent of balanced diet, thus ensuring nutritional security. Students, vegetables are often referred as protective foods by the role they play in preventing many diseases and improving digestion. Processing the vegetables to preserve them has been taught to man by the nature. Low temperature prevailing in the frigid regions of the world helped the humans to extend the shelf life of perishable foods. Even in the tropical areas of the world, people used the sun to dry out perishable foods. In most of the cases, low and high temperature were the principal agents used to preserve many foods. Various techniques for preserving vegetables include dehydration, canning, fermenting, etc. In the recent times, many advances have been made in this sector to provide ready to eat and ready to make like foods. As a result, we can expect food service industry to grow manifolds in coming future. Owing to the perishable nature of vegetables, weak infrastructure at farm level, insufficient demand at times and poor transportation, the growers sustain substantial losses. Dear students, the loss is considerable during the post-harvest glut, thus compelling the grower to feed the produce to cattle or allowing it to rot. Processing vegetables intends to supply safe, nutritious, wholesome and acceptable food to consumers all round the year. Moreover, it aims at earning foreign exchange by exporting semi-processed or finished products. The processing of vegetables can help to diversify economy, generate rural as well as urban employment, reduce post-harvest losses, elevate nutritional stress of locals through consumption of their own produce in off-season, generate income and develop value-added products. Processing criteria. There are certain factors which determine whether a particular vegetable should be processed or not, and these are need of a particular vegetable in processed form, capacity of raw material to withstand processing, and uninterrupted supply of the raw material. Varietal influence. A vegetable processor must appreciate the substantial differences that cultivars of a given vegetable possess. Varietal differences further extend into suitability for processing methods like canning, freezing, pickling or dehydration. Harvesting criteria. There is a time during maturity of a vegetable when it is at its peak quality from the standpoint of color, texture and flavor. But this peak quality is quick in passing and may last only a day. Thus, harvesting and processing of several vegetables are rigidly scheduled to capture this peak quality. Pre-processing operations. These pre-processing operations include washing, sorting and grading, skin removal or peeling, blanching. The main purpose of washing a vegetable before processing is not only to remove field soil and surface microorganisms, but also to remove fungicides, insecticides and other pesticides. Washing water contains detergents, or other sanitizers that can essentially completely remove these residues. Sorting and grading. This step covers two separate operations. First one being removal of non-standard vegetables and possible foreign bodies after washing. Quality grading based on varietal, dimensional, sensory and maturity stage criteria. Skin removal or peeling. Some vegetables require skin removal before they can be processed further. This can be done mechanically, chemically or thermally. Vegetables like potatoes and root vegetables can be peeled mechanically with abrasive devices. And chemicals like hot alkaline solution of lye of about 0.5 to 3% at 93 degrees Celsius for 0.5 to 3 minutes can prove effective in skin removal of soft skinned vegetables like tomatoes. Vegetables with thick skins such as beets, potatoes, carrots, sweet potatoes may be peeled with steam at 10 atmospheric pressure as they pass through cylindrical vessels. This softens the skin and the underlying tissue, and when the pressure is suddenly released, steam under the skin expands and causes the skin to puff and crack. The skins are then washed away with jets of water at high pressure. Blanching. Blanching is the special heat treatment given to inactivate enzymes. It should not be indiscriminate where too little becomes ineffective and too much damages the vegetables by excessive cooking, especially where the fresh character of the vegetable is subsequently to be preserved by processing. Students, the main purpose of blanching is to inactivate enzymes, and the most heat resistant enzyme in vegetables are catalase and peroxidases. If both of these enzymes are destroyed, then the other significant enzymes in vegetables are also considered inactivated. Sensitive chemical tests have been developed to detect the amounts of these enzymes that might survive a blanching treatment, and the necessary time to destroy these indicated enzymes in different vegetables has accordingly been devised. Blanching as a unit operation is a short duration heating in water or steam at the temperature of about 100 degrees Celsius or below. Steam heat treatment can also be applied instead of water blanching as a preliminary step before freezing or drying, as long as the preservation method is only used for enzyme inactivation and not to modify consistency. Cooling of vegetables after water or steam blanching is performed to avoid excessive tissue softening and is done immediately after these operations. Processing operations. Different methods are employed for processing vegetables like canning, drying or dehydration, etc. Drying or dehydration of vegetables. Dear students, drying is probably the oldest method of food preservation known and practiced by mankind. Drying brings about substantial reduction in weight and volume, thus minimizing packing, storage and transportation costs, and also enables storability of the product under ambient temperatures, which is especially important for developing countries. In order to assure products of high quality at a reasonable cost, dehydration must occur fairly rapidly. Four main factors affecting the rate and total drying time are: number 1, particle size and geometry of the food to be dried, geometrical arrangement of the foodstuff in relation to heat transfer medium, physical properties of drying medium like air velocity, humidity, temperature, etc., and characteristics of the drying equipment. Drying methods. The three basic types of drying processes are sun drying and solar drying, atmospheric drying and subatmospheric dehydration. Factors which determine the selection of a particular dryer or drying method are: form of raw material and its properties, desired physical form and characteristics of dried product, necessary operating conditions and unit operation costs. Determining dryness. Determination of dryness of vegetables is a very important criterion. Vegetables should be dried until they are brittle or crisp. At this stage, they should contain about less than 10% moisture content. Packing and storage. Dried foods are susceptible to insect contamination and moisture reabsorption and must be properly packaged and stored. First, cool the dried food completely, as packing warm food will cause sweating, which could provide enough moisture for molds to grow. Packing foods into clean, dry, insect-proof containers as tightly as possible without crushing will help retain quality of dried food. Dried vegetables should be stored in cool, dry and dark areas. Recommended storage periods for dried foods range from 4 months to 1 year. As food quality is affected by heat, the storage temperature helps determine the length of storage. The higher this temperature, the shorter the storage time. Dear students, storage temperature helps reduce or inhibit the speed of all physicochemical, biochemical and microbiological process and thus prolongs storage period. Dried vegetables can also be made into powder. In order to obtain these finished products, there are two processes: drying of vegetables down to a final water content below 4%, followed by grinding, sieving and packing of products, or vegetables can be boiled and then sieved to be made purees, which are then to be dried on heat surfaces or by spraying in hot air. Modern solutions are oriented not only to maintain product moisture during storage, but also reduce this parameter by the use of desiccants. With desiccants, product moisture can be reduced to even below 4%, and this inhibits or reduces the biochemical and microbiological processes during storage. Calcium oxide is the most commonly used desiccant for this purpose. Another factor that can deteriorate dried or dehydrated vegetables is atmospheric oxygen through the oxidative phenomena that it produces. In order to eliminate the action of this agent, some packing methods under vacuum or in inert gases like carbon dioxide or nitrogen are used. In order to avoid the action of oxygen, ascorbic acid may also be added, which acts as an antioxidant. Vegetable canning. The aim of canning is to destroy microorganisms in the food and prevent their recontamination. Heat is the most common agent used to destroy microorganisms. However, removal of oxygen can be used in conjunction with other methods to prevent the growth of aerobic microorganisms. Dear friends, it can be said that canning is preservation of foods in the sealed containers, which usually implies heat treatment as the principal factor in prevention of spoilage. Mostly, canning is done in tin cans, which are made of tin-coated steel or in glass containers. One of the major differences in the sequence of operations between fruit and vegetable canning is the blanching operation. Canned vegetables generally require more severe processing than fruits because the vegetables have much lower acidity and contain more heat-resistant soil organisms. Dear students, we know that vegetables often contain disagreeable flavors or organic compounds which should be removed before canning. Therefore, they are usually blanched before being filled into cans. Students, let's see how canning is done at a small scale. To start with, the vegetables for canning should be tender and reasonably free from soil, dirt, etc. Next stage for canning is sorting and grading. After preliminary sorting, vegetables are graded. This is necessary to obtain a pack of uniform quality as regards size, color, etc. It is done by hand or with the help of grading machines. Washing. Graded vegetables are washed either by soaking or agitating them in water. The washed vegetables are prepared by blanching, etc. Can filling. The cans are washed with water or subjected to a steam jet to remove any adhering dust or foreign matter. Cans are filled either by hand or by automatic can filling machines. Brining. Brining is done to improve the taste and fill up the interspaces between vegetables in the can and to facilitate processing. Brine should be added at a temperature of 79 degrees Celsius to 82 degrees Celsius, leaving suitable headspace in the can. Lidding or clinching. It is the process in which lid is partially seamed to the can. The lid remains sufficiently loose to permit the escape of dissolved as well as free air from the contents. Next step in canning involves exhausting. It is the process necessary to remove practically all air from the contents. Removal of air helps in better retention of vitamins, especially of vitamin C. Exhausting helps in prevention of bulging of the can, reduction of chemical reaction between the container and the contents, and prevention of excessive pressure and strain during sterilization. Exhausting can be done either by heat treatment or by mechanical means. Sealing. After exhausting, the cans are sealed by machines called as double seamers. Processing. Processing consists in determining just the temperature and extent of cooking that would suffice to eliminate all possibilities of bacterial growth. Vegetables which are non-acidic in nature require to be processed at higher temperature of about 115 degrees Celsius to 121 degrees Celsius. The center of the can should reach this high temperature. It is done in open cookers, continuous non-agitating cookers, or in continuous agitating cookers. Next step in canning vegetables involves cooling. After processing, the cans are cooled rapidly to stop the cooking process and to prevent steak burning. Cooling is done by immersing cans in tanks containing cold water, spraying with jets of cold water, turning in cold water into the pressure cooker, exposing cans to air in small lots when water supply is scarce. Then the last step involved in canning vegetables is labeling, storing and packing. The cans are to be labeled by hand or by machine and packed in wooden cases or cardboard cartons in standard packings. They are dispatched and stored in a cool and dry place. Aseptic canning is the latest development in canning. It actually is a high temperature, short time sterilization process. It combines flash sterilization and cooling with aseptic methods of packaging for fluid and semi-fluid products, thus eliminating the retorting and subsequent cooling phases. Aseptic canning is used commercially for bulk packing of products. It has many advantages over conventional canning but is a high cost technology and requires different infrastructure from conventional canning. However, the high installation cost may be compromised with the high quality of end product, resulting in higher returns. Dear students, with this we conclude, and I hope that you have understood some basic concepts regarding vegetable processing. Thank you.